POLYCET 2017 World Question Paper Physics Explanation Part 3 video from the bits 86 to 90. So 86th bit, what is, student? 86th one we can see. Which among the following is responsible for an induced current in the coil? So for the induced current, the responsible thing in the coil is change in the magnetic flux. This is change in the magnetic flux through the coil. Next one, 87 students. A particle of charge Q, mass M, moving with speed V, perpendicular to the magnetic field of induction. The radius of the circular path. So in the magnetic field, a charge Q, a charged particle of charge Q, mass M is a moving with speed V, perpendicular to the magnetic field of induction B. So then what is the radius of the circular path? So you can see, students, the explanation, 87th one. For example, it is a magnetic field along the circular path. Inside the magnetic field along the circular path, a charged particle with the charge Q is moving. Now we want to find radius. What is its radius? So this is the magnetic field. So mass of the charge is M. Mass of the particle is M. Charge of the particle Q. Speed of the particle V. So what is the radius of the circular path we want to calculate? So when the charges are moving perpendicular to the magnetic field, then magnetic force acting on the charge is given by the formula B into V into Q. It is equation 1. But magnetic force here equal to the centripetal force. This is the magnetic force. So this magnetic force equal to centripetal force. Because the particle or body moving along the circular path means there must be centripetal force Fc. But you know centripetal force formula is given by mv square by r, where m is mass of the particle, v is the speed of the particle, r is the radius. So now it is equation 2. So from equation 1 and 2, we can write mv square by r. This f is mv square by r is equals to bvq. V get cancelled. Then we can get mv by r is equals to bq. By the cross multiplication, bqr is equals to mv. Then r is equals to mv by bq. So this is the option. So this is the option. Here it is. You can see the option. This is the option. Next one, students, 88. A coil has 200 turns. If an increase in the magnetic flux through one turn of the coil 0.001 Weber in 0.1 second, then maximum induced EMF we want to calculate. 88 students. Number of turns denoted by N, which is given as a 200, and magnetic flux denoted by d pi is 0.001 Weber, and time dt is a given, students, 0.1 second. Then we want to calculate EMF denoted by epsilon. This is symbol epsilon. So from Faraday's law of electromagnetic induction, epsilon is equals to n into d pi by dt. This is a formula in electromagnetic induction. Epsilon is equals to, this is 200, d pi means 0.01, dt means 0.1 second. Then epsilon is equals to, this will be on multiplying 0.2 by 0.1. 0.2 into 0.1 means we can write 10. It will be 0.2 into 10 by 1. Then epsilon is equals to 0.2 into 10 means 2 by 1. That is 2 volts. So this is the option is, students, for 88 option is, so you can see option is 2 volts. Then next one, a metal ring is inserted through the soft iron cylinder which is wounded with the copper wire. When AC is supplied between the ends of copper coil, then metal ring is levitated on the coil. So you can see this one in the diagram in electromagnetism in activity, students. So in the activity you can see this is, it is a soft iron core, soft iron cylinder. Around this one copper wire turns are there. These two ends are connected to a AC, that is a plug, and it is a metal ring. So when these two ends connecting and switch on, it is levitated, it rises like this. So this is the bit here. So metal ring is levitated on the coil. Next one, students, last one. Tesla is the SI unit for magnetic flux density. Tesla is the SI unit for magnetic flux density.